Okay, let's jump right in. Back in 2023, Amazon dropped a blog post about an architectural mistake that absolutely broke the engineering internet. I mean, it grabbed everyone's attention instantly. The Prime Video team had just taken their highly sophisticated, heavily distributed microservices architecture, completely ripped the whole thing out, and replaced it with a monolith. And here is the kicker. By ditching microservices for this specific system, their infrastructure cost dropped by a staggering 90%. And this is Amazon we're talking about here. They practically invented microservices. They were literally the poster child for this exact architectural style, and now they were actively walking it back. The engineering community had a full-blown meltdown trying to figure out what this actually meant. If the actual pioneers of microservices are abandoning them, were microservices just a mistake all along? Like, was the entire last decade of industry standard architecture advice fundamentally wrong? I've been thinking about this a lot, and the real answer is actually a bit more uncomfortable than either the pro-microservice or pro-monolith camps really want to admit. So let's unpack exactly what happened here, and more importantly, what we can learn from it. To really understand why this Amazon story matters so much today, we kind of have to step back into a time machine. We are going to the early 2000s. Companies like Amazon and Netflix were scaling at a blistering pace, a pace that literally nobody in the industry had ever dealt with before. And because of that unprecedented growth, they were running headfirst into a very specific structural wall. Back then, companies were facing the monolith nightmare. Now, look, when a monolith works, it's elegant. You got one code base, one database, one deployable unit. It's straightforward. But when you need to change it at immense scale, when you have 10 or maybe 50 different teams all touching the exact same code, it becomes an absolute nightmare. You literally can't deploy the checkout service without risking taking down the entire recommendation engine. Every single change becomes this massive full system risk. So the industry created the microservices dream. The idea was simple. Break it apart. Give each function its own service, its own team, its own deployment pipeline. Suddenly, you can deploy that checkout service without touching anything else. You get independent deployment, isolated scaling, total team autonomy. These were genuine, massive advantages. And when the rest of the industry saw it working for Amazon and Netflix, well, everyone ran to copy it. Microservices quickly became the default answer to scale. Alright? But nobody actually asked what it would cost to run all of these beautiful independent services. The glowing conference presentations conveniently forgot to mention one absolutely crucial detail. The moment you take a monolith and split it into dozens of microservices, you haven't just simplified your code. Actually, you've created a distributed system. And distributed systems, yeah, they do not manage themselves. Let's think about the crushing weight of what that actually entails. We call this the invisible labor cost. First off, you need Kubernetes just to orchestrate your containers. Sure, it handles service discovery and load balancing, but managing it is entirely its own full-time job. It requires dedicated platform engineers. Then, you're going to need a service mesh like Istio to handle encrypted communication. And let me tell you, one misconfigured traffic policy and a sea of YAML files can silently break everything in production. Then you have to stack on centralized logging, because otherwise debugging a failure means digging through dozens of individual containers before they randomly restart. Then add distributed tracing, just to follow a single user request across the maze. And finally, you've got the grueling 24/7 on-call rotations to cover this massive spinning web of complexity. Your infrastructure bill, that's visible. It's right there on your monthly cloud invoice. But this labor cost is totally invisible. It lives in headcount, in constant debugging, and in infrastructure teams that are just too busy keeping the lights on to actually ship product features. And beyond the human cost, there is a very real physical cost here. Think about it. In a monolith, when one part of the system needs to talk to another, it's just a simple function call. It happens in nanoseconds. Boom. But in a distributed system, that exact same operation is now a network round trip. Every single service call crosses a physical network boundary. The system has to serialize the request, send it over the wire, and deserialize it on the other side. Every single hop adds latency. So when a user clicks play on a video and a dozen services need to talk to each other just to authorize the stream, that latency drastically compounds. Conway's law unpacked the people problem. We've talked a lot about the technical costs, but this architecture problem rapidly becomes a people problem. You see, Amazon's original insight, the thing that actually made microservices work for them in the very beginning, wasn't just technical, it was an organizational solution. It really all came down to this famous principle, the two pizza team. Amazon mandated that if you can't feed a team with two pizzas, the team is simply too big. Though, you know, depending on the appetite of your engineers, your mileage may definitely vary on that one. But seriously, they created these small, fully autonomous teams where each team owned a microservice end to end. They built it, they ran it, and they were the ones getting paged at 2 a.m. when it broke. Having that real skin in the game completely changed how their software was written and maintained. But, and this is a big but, that model only works if an enterprise actually implements the culture. And honestly, most just don't. The absolutely crucial point to understand here is Conway's law. This was articulated way back in 1968, and it states that organizations design systems that mirror their own communication structure. And this right here is exactly where the microservices dream falls apart for most companies. They decide they want to modernize, right? So they take the exact same massive, slow moving team that was maintaining the monolith, they split the code base into 20 services, and they call it a digital transformation. Think about your own company for a second. If you split a code base into 20 services, but you keep the exact same massive management structure, your org chart didn't actually change. Only the deployment units change. So you end up getting all the operational complexity without any of the organizational independence. All that coordination overhead you try to eliminate, it comes right back as endless cross-team Jira tickets. If your communication structure doesn't change, your system architecture is not going to save you. Why did Amazon Prime Video make headlines for walking back their microservices? Let's apply everything we just talked about to their specific case study to resolve this. So the Prime Video team was looking specifically at their video quality monitoring pipeline. It had been built as this highly distributed microservices system with separate compute resources and completely separate scaling policies for every single component. But when the engineers actually sat down and looked at the data, they realized it was a tightly coupled processing pipeline. Basically, every single step needed to complete before the next step could even begin. Because of that strict sequence, there was absolutely zero independent scaling to be gained. You couldn't scale up step 3 without also scaling up steps 1 and 2. It just didn't work. And worse, the inter-service network calls were causing massive bottlenecks. The overhead of sending heavy video data back and forth between these services was dragging the whole system down. So what did they do? They collapsed it back into a single monolith. And the result? Not only did their infrastructure costs drop by 90%, but scaling actually improved because they completely eliminated all that network latency. It's like this. They were a chain. And honestly, distributing a chain doesn't make it any faster. It literally just adds links. For this specific video quality monitoring workload, Prime Video was paying the absolute maximum complexity tax of a distributed system without collecting a single one of the benefits. They had no independent scaling and no team economy. Now, it's incredibly important to note here, they didn't abandon microservices across their entire platform. Things like their streaming infrastructure and recommendation systems remained highly distributed. They just recognized that for this specific chain, the architecture was simply wrong. So, what is the final balanced takeaway here? It's not that microservices are inherently bad, and it's certainly not that monoliths are magically back to solve all our problems. The truth is actually much simpler. The architecture that wins isn't the most sophisticated one, it's the one your team can actually operate. The real question you have to ask yourself is what level of complexity your organization can actually absorb. Are you paying for complexity that is delivering real value like team autonomy and isolated scaling? Or are you just paying for complexity for the sake of complexity? To realize the genuine benefits of microservices, you need the full prerequisite stack in place. It requires a total organizational transformation, not just buying a new technology. The Amazon Prime Video case proves that complexity has an invisible price tag, and you have to make absolutely sure your organization can absorb it. You know, the most expensive systems out there aren't necessarily the ones with the highest cloud bills. They're the ones whose real costs, the hidden labor, the compounding latency, the operational friction, never actually show up on any invoice. Microservices are a fascinating example of this, but these patterns repeat everywhere in technology, from databases right down to organizational charts. So I want to leave you with this thought. What is the most expensive architectural decision you have ever seen made without counting the real cost? If you found this helpful, don't forget to like, subscribe, and drop a comment if you have any questions. Thanks for watching and see you in the next video.